Welcome in our Senior Design Virtual Conference, Session A of Mechanical and Aerospace Engineering. My name is Dan Kujawski. I will host this morning session. So please mute all your mic if you don't speaking. Presenting student, of course, will have on their camera so we can see them. After presentation, we will have question and answer session, and I will facilitate that. You can type your question in chat room, or you can unmute your microphone and just ask. So I think we have 9 o'clock right now. Maybe I forgot another co-host is Dr. Biogas Digester. And so I think that time it's 9 o'clock. So Tim, the virtual floor, it's yours. You can start your presentation.
All right. I'm Dan Devereaux, and I'm joined here by Andrew Hobson and Yash Jenge. Our project that we'll be presenting on is carbon footprint reduction for Allegan County. We'd just first like to thank our faculty mentor, Dr. Biogas Digester, and our industry mentor, Scott Corbin, for continuing to work with us through this project and help us along the way. So the purpose of our project is to design a comprehensive strategic action plan to reduce the overall carbon footprint of Allegan County. This would be a plan that Allegan County would be able to use to decide on their budgeting numbers in the future for the next 10 to 50 years, and would just help them make governmental decisions in regards to the environment. The areas of focus that we decided to look at are electricity generation and consumption, residential and industrial heating, and transportation. So a little background on Allegan County. It's just a little northwest of Kalamazoo. The county stretches between Plainwell and the city of Holland. It's mostly a rural area, and the economy is primarily agricultural and based on tourism. It has a large section of shorefront on Lake Michigan, and there's about 825 square miles of land and a population of roughly 118,000. So looking at some data gathered in 2019 for the U.S. greenhouse gas emissions by sector, this chart on the left shows the total emissions for the last 30 years per year. And on the right, you can see the major sectors that contribute to greenhouse gas emissions. So we were able to look into each of these categories to see what could be changed in Allegan County in order to reduce the greenhouse gas emissions.
Electricity generation, which is the second largest source of greenhouse gases. About 40% of total emissions are emitted from power generation. Carbon dioxide had the highest impact globally on the total greenhouse gases, leading to adverse effects such as global warming. Traditional power generating techniques and fuels need to be altered to reduce carbon emissions. Power plants, until 2015, coal fueled most of the power plants in the United States. After 2015, it was replaced by natural gas. Now that is the top producer of electricity in the US. Making that move already reduced about 50% of carbon emissions because nitrogen gas burns approximately emits approximately half as carbon as coal. So that's good, but we need to push it even further, implement more and more renewables to push towards the goal of achieving carbon neutrality in the county. So the major power plants that currently exist in Allegan County, there are 3 major plants that are of scale to be included in this. There's 2 natural gas-fired power plants, the Cloud Van Dyke and the 419 East 48th Street. Cloud Van Dyke is 47.8 megawatt capacity. The other one is 161.7 capacity, and these are the power generating average power generating numbers of them in the years 2016 to 2018, and those are the carbon emissions, the average carbon emissions of the same years. And then there's the Allegan Dam, which has only the capacity of 2.6 megawatts, but you can see that it generates much more power than the Claude Van Dyke power plant, because dams, the ratio of the power generation to the capacity of the dams are larger. So we wanted to look a little bit about injecting hydrogen in the natural gas-fired power plants that currently exist in the county. And this is kind of a schematic from GE that they show how the green hydrogen can be reused in some of these power plants. They do need some turbines, some specific turbines, better efficiency turbines that can burn this hydrogen, and they do have that. So we did look into one for the current. We did look into one to replace the current one at Cloud Van Dyke. Next slide. So this is one of the turbine that we sized up according to whatever Cloud Van Dyke has right now. This one is a slightly more capacity and can generate much more electricity than that one. And then we size it up so that it's going to run on a combined, one-by-one combined cycle, 2,645 operating hours. And if we inject 30% hydrogen, that is, and we're trying to push so that all that hydrogen is green hydrogen that's generated from renewables, then we would get 11.6% of carbon offset and about $38,000 in tax savings if this was to be implemented. And there's some infrastructure requirements. It shows on the left side where it shows it's going to need 26,000 gallons of water a day for electrolysis and about 27.8 megawatts of renewable energy to generate this. We tried to get pricing on that. We couldn't get exact pricing on that, but we did get, because they do not quote to students or for research purposes, but we did get an estimated cost for these turbines, which is listed there. Hydroelectric power plants in Allegan County. Currently, there is only one, the Allegan Dam, as we discussed, which is owned by Consumer Energy. There are, however, several other dams that exist in the county which do not have a hydroelectric plant on them. And according to the International Renewable Agency, the major hydro projects between 2010 and 2019 had the average cost of about $2,550 per kilowatt for the construction cost of the dam and the hydropower plant on top of that. But if dams already exist, just installing the hydropower on an existing dam can cost as low as $450, which is a good thing because Allegan County does have some more dams that do not have any hydropower on them, and that can be easily incorporated. Solar farms in Allegan County. There are currently not any large-scale active solar farms in Allegan County. A new $25 million, 20-megawatt solar farm has just been approved in the Lee Township near Pullman, Michigan. This solar farm should produce about 30,000 megawatt hours of electricity annually, which will really help push towards the renewable resources in the county. Solar panels are getting more and more efficient, cost efficient these days, so they do need to be incorporated. The average construction cost of solar farm in the area is about $2,288 per kilowatt right now. Wind farms in Allegan County, again, there are not any large-scale active wind farms in the Allegan County currently. In 2010, Michigan Sea Grant, along with Grand Valley State University, performed an analysis in the West Michigan Wind Assessment Project, and it was discovered that abundant amount of wind resources were possessed by the coastal regions of Michigan, including the Allegan County. Based on this research, in 2012, City of Holland planned to lease hundreds of acres of land for potential wind farms, but the budgeting at the time and the return of investment, when it was evaluated, they decided to not proceed with that at that time. Current budgets for renewables need to be reevaluated to see if this can be reconsidered for same or different locations. The current EI average cost for wind farms in the area is $1,500 per kilowatt. These are the costs for solar and wind power stations that we came up with. First of all, right now, as much as power is generated in Allegan County is in the ratio to the power that is used is very less. Around 600,000 kilowatt hour, 600,000 megawatt hours a year is used by the Allegan County, but only about 100,000 is produced. So we are sizing up the solar farms and wind farms and hydroelectric power plants in the county to make the county self-sufficient and pushing it towards carbon neutrality. So those are the size listed there, and then I have the 25% adoption, 50%, and 75% adoption, which means if 25% of that size is met, those are the kind of costs, governmental costs associated with that, with the associated carbon offsets, then the 50% and the 75%, and we went by a 10-year mark, 2030 for adopting 25, 2040 by adopting 50, and 2050 for 75%. And those are the carbon offset numbers, as we can see from either one of those. Efficient power usage is just as important or more important than efficient power generation. 357,000 megawatt hours of electricity was consumed by residential usage in 2016, and a similar number is by industry and commercial use. Along with energy efficient practices, implementation of a few smart devices for residential use could really lead to some carbon offsets. So we did put a list of those devices together and did some research to find what those efficiency numbers were and what the impact would be. Should be in the next slide. So those are the list of smart devices right there. And then we found out what the percent reduction in the power usage for that bit would be, what the total cost of the devices itself are. Then we suggested what the government rebates should be for those devices, and then what would be the government cost for all that. And then we looked up the data from 2016 of total homes in the year of 2016. And then we figured out what it would be total percent reduction in power usage per household. And then we figured out dividing the total numbers by dividing the total usage by the total homes, finding the average consumption data, and then ran those numbers to see if 30% of the homes in the county adopt this. And we put the date by 2030. Those were the energy savings they would get, and that would be the total carbon offset, and that is how the government, that is how much the government would have to pay back in rebates, so the governmental costs associated with that. So that's the 30%, 60%, and 90% by 2030, 2040, and 2050 right there.
Yeah, so because Allegan County is largely agricultural in its economy, we decided to look into a way that we could reduce carbon emissions from livestock waste. And our design was for a biogas digester, which essentially uses bacteria to break down the manure, and it can create methane and reduce carbon emissions by 88%. This also reduces air and water pollution in the surrounding area, and the manure can be applied to crops as fertilizer after it's broken down and solidified. Some barriers to this, though, is that because small farms would be adopting this technology, the high capital costs would make it hard for them to do so. So we calculated that a carbon offset price of $26 per ton of CO2 displaced would be required in order to make this financially viable for farms in Allegan. The third largest source of greenhouse gases that we looked into was industrial and residential space heating. 55% of energy used in an average American home goes towards heating. And the average home in Allegan County specifically, we calculated to be around 23 kilowatt hours of electricity per day that they would be using. Total annual carbon emissions for heating homes in the county was roughly 170,000 metric tons of CO2 output into the atmosphere. This averaged about 4 metric tons of CO2 per household per year. And in Michigan specifically, natural gas is the main source of heating in residential sector. So one technology that should be adopted is using heat pumps for heating instead of natural gas. This is twice as efficient as the gas-powered furnaces and the carbon emissions that can be reduced from space heating would be nearly half compared to fossil fuel-driven heat sources. These can be retrofitted into existing heating systems, enabling fossil fuel power heaters that currently exist to only operate when the load is at peak volume in basically the dead of winter. Otherwise, the heat pump would be able to handle the heating needs. Geothermal is the most efficient form of using a heat pump, and the emissions reduction can be around 60%. You can see in the figure that the coefficient of performance for heat pumps, a study down in Minneapolis, Minnesota, and Columbus, Ohio, shows that it's almost 3 times that of any gas furnace. And on the top, the percent of CO2 reduced in the emissions is anywhere from 55 to 71% as compared to electric, oil, LPG, or mains gas heating. So another thing that we suggest Allegan take action on is waste heat recovery. This is essentially a system that would take waste heat from industrial processes and repurpose it for space heating in industrial and residential spaces. In our research, no locations were found with any significant waste heat output in Allegan County, but a more in-depth study could be done in the future. One way to use this technology is drain water heat recovery, which uses the technology to get heat from wastewater going down the drain. These systems are affordable for individuals to buy. They pay for themselves in 2.5 to 7 years and have a long lifespan of 30 years. This could reduce an average home's CO2 emissions by 2.5 tons per year. So here is a table showing the cost for the government to supply a 20% rebate for the biogas digester, heat pumps, and drain water waste heat recovery. There's also the amount of carbon emission reduction per 25% adoption in the county, 50% adoption, and 75% adoption.
The third category we looked at was transportation, and this category is the largest contributor of greenhouse gases worldwide. Our analysis found that due to Allegan being a mostly rural area, a transition to hybrid and electric vehicles would have a greater impact than the implementation of more public transportation. Recommendations were made for the Allegan public school system, our bus system, and analysis was done for the carbon emission offset regarding to tourism. So the Allegan Area ESA provides buses to 5 school districts, and currently 1 electric bus has been put in use in Fenville, which is in Allegan County. These diesel buses produce 658 tons of CO2 per year, and altogether the buses run about 500,000 miles per year. A transition to electric vehicles would save an estimated 198 tons of CO2 over the lifespan of the bus. And if 10 buses were replaced, by 2030, an estimated 1,742 tons of CO2 would be offset. And there are currently funds available from the EGLE, and these funds would extend towards the end of the summer, and they'd be used towards additional busing, where each bus costs about $350,000, but includes a level 2 AC charger. And this transition would also be for students' health, given that tailpipe emissions have a detrimental effect on students' health, can even lead to lower test scores. So due to most main car manufacturers converting to electric vehicles, many by 2035, recommendations were made to Allegan County regarding an increase into the power grid capacity. A public education campaign that raises awareness for subsidies for electric vehicles was also recommended, with Consumer Energy $500 subsidy for an at-home car charger and up to $7,500 in federal grant money towards electric vehicle purchases. A 15% conversion to electric vehicles in Allegan County would result in a reduction of 115,000 tons of CO2 reduced per year. Analysis was done of tourism in Allegan County. Allegan County hosts a few major events, including Tulip Time and the Allegan County Fair. Tulip Time in Michigan brings in 500,000 visitors per year and brought in $48 million directly and $1.3 billion indirectly for 2016. Our analysis concluded that for Tulip Time, the Tulip Time contributed approximately 1% of all greenhouse gas emissions for Allegan County annually, and 6,000 megatons of CO2 was generated by travel to and from Tulip Time, compared to the 807,000 generated countywide. And the conclusion was that tax revenue generated by this event could be used for sustainability projects such as EVs, and that would outweigh the environmental cost of travel to and from this festival. So this shows the total possible carbon offset for all of the categories we studied. Some examples are natural gas-fired power plants would save 4.7 tons of CO2. Adding additional renewable sources would save approximately 303,000 tons of CO2. More efficient residential usage would save 28,000 tons of CO2 annually, and the biogas digester would save 200,000 tons of CO2. Geothermal heating would save about 60,000 tons of CO2, and the drain water heat recovery would save 63 tons of CO2. A 15% conversion to electric vehicles would save 115 tons of CO2, and the diesel for each diesel bus, 198 tons of CO2 would be saved per lifetime. And the total cost, or the total carbon emission offset for Allegan County, based on all these recommendations together, was 782,000 tons of CO2 per year. These are our sources. And are there any questions?
The presentation is open now for comments and questions. As I mentioned, you can unmute yourself, ask the question, or type the question in chat room.
I have a question, guys, to start. So my question to the group is, what new skill each of you learned during this project?
I'll go first. I think I learned a little bit how to size the turbines based on the capacity that's required and the power generation per year that's required, and to look at the efficiency numbers. So I was able to look at the existing turbines in the power plant of the county and size something similar to that. So I've never done that before. So I would say that's a new thing I learned.
Yeah, I would say I learned a lot about doing the research into numbers like total number of carbon emission offset that could be done in Allegan, kind of, and like the carbon emissions specifically from heating in homes, doing those calculations and doing the research to find those kinds of numbers, something that I haven't really done similar things to in the past.
Yeah, so I learned a lot about electric vehicles and what would be required for a power grid in order to support an increase in electric vehicles and how fast we are currently transitioning over.
And you guys have some question in chat room?
Okay, so I see there's a question. What do you predict will be Allegan County's greatest challenges if they implemented all of the changes you have suggested? Well, the number one challenge would always be budget. If there was an unlimited budget, carbon neutrality could be reached quite a bit quicker. So a combination of private industries working with government subsidies would be our recommendation for combined effort in order to transition.
Yeah, just to follow up on that, yeah, the greatest challenge would be the return of investment, because it's going to take a while to offset the cost associated for the changes. It's going to take a few years, so that will definitely be a challenge to get all the return of investment back to be able to afford that kind of changes. So that's why we kind of gave them a breakdown of prices so they can decide how much do they want to spend to see how much changes. So, yep.
Yeah, to add on to that as well, a lot of the changes that we recommended are something that would have to be adopted by individuals, individual organizations or companies, and just the government would have to make some kind of subsidies or grant programs in order for that to be viable for them to make that decision.
Other questions? So maybe I can ask one. You mentioned many different sources where CO2 is. Which one will be in your recommendation, should be attacked first? Which one will give you the best answer for your quest which you pose there? That means which source you will recommend as a first to implement?
I think as transportation is the top source of the leading source for carbon emissions. But again, we are talking about a county, so it would be debatable to do transportation or electric generation. There's a lot of offsets with power generation if renewables were used. Those numbers are definitely significantly high, and that I think electric generation and efficient usage of it, more generation than usage, would be the one to tackle that would make the most significant difference on a county level.
Thank you. Any more questions? If there is no more question, thank you very much for presenting team, also attending family members and all the audience. The next presentation will start at 9:30.